I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about algebra and differentiation. Now the question that I've chosen to go through here is 2019 paper 1 question 3, and in the first part of this question we've been given a function f of x. It's minus x cubed plus 4x squared plus x minus 2. We've been asked to find the values of f in the domain x is between minus 1 and 4. In other words, for all the x values between minus 1 and 4, so minus 1, 0, 1, 2, 3 and 4. And we've been asked to then use these values to plot your points. Now I've just done one of them out and I've given you the rest of the solutions. So the first one obviously I want to use is x equals minus 1. So that just means that you sub into the original function. I'm going to sub into this, except everywhere there's an x, I'm going to sub in a minus 1. So when I did that, that means I'm looking for f of minus 1. I just rewrote this, except everywhere there was an x, I've plugged in a minus 1. Now obviously your best bet here is probably to plug it into your calculator, because you could easily make a sign error here. But if you plug it all into your calculator like that, then you would end up getting that the answer is equal to 2. Nonetheless, I've worked it out here. Minus 1 to be cubed is minus 1. Minus by minus gives you a minus. Minus 1 to be squared is plus 1, because minus by minus gives you a plus. And then at the end I just have minus 1 minus 2. Then here I have a minus by minus, which is plus 1, 4 by 1 is 4, and minus 1 minus 3, minus 1 minus 2 is minus 3. If I add these together, I just get 2. So that means that when x is minus 1, y is equal to 2. So obviously you just follow the exact same process. You do that for 0, you do it for 1, you do it for 2, for 3, and for 4. And the answers you should have gotten are 2, minus 2, 2, 8, 10, and 2. So these are the coordinates we'll use to plot our points. Our first coordinate is the coordinate minus 1, 2. The second coordinate is the coordinate 0, minus 2. My third coordinate, the x is 1, the y is equal to 2. My fourth one, I have the coordinate 2, 8. Then I have the coordinate 3, 10. And then I have the coordinate 4, 2. Now I can just plot my graph and finish off A part 1. So once we've worked out our coordinates, we just plot them on our graph. The first one is x is minus 1, y is 2. Then x is 0, y is minus 2. X is 1, y is 2. X is 2, y is 8. X is 3, y is 10, and then x is 4, y is 2. Remember, this is a curve. Because there's an x cubed, it's a curve. So you cannot use your ruler when you're joining it up. It has to be freehand. Whenever you're drawing a line as the opposite, you have to use a ruler. In part 2, it asks me to use my graph to identify the roots of the function. Now you need to realize that the roots refer to where it crosses the x-axis. And it says estimate, so based on your graph you need to estimate what that is. Now the form you should write roots in, you need to write roots in the form x equals something. X equals whatever the number is. So this root here on the left hand side, it's clearly between 0 and minus 1. Now on the marking scheme, if you're perfectly accurate, what this should have worked out for you is minus 0.7. So roughly there, where it crosses the x-axis, x is equal to minus 0.7. And on the other side of it, where it crosses the x-axis, x is equal to 0.7. They're the values that are given in the marking scheme, so there if you're perfectly accurate. Now obviously if it says estimate, you're not expected to be perfectly accurate, but you are expected to be in and around minus 0.7 and 0.7. So that's my final answer for A part 2. Now in part B of this question, we're asked to find f dash dash x, the second derivative of f of x. In order to get the second derivative, you need to first of all get the first derivative. So we need to differentiate our function, that'll give us the first derivative, and then differentiate that again. So I need to differentiate twice here. So the first thing I'm going to do is I'm going to try and find f dash x. In order to differentiate, you bring the power of x in front. So in this case, it's going to become a minus 3. And the power of x decreases by 1. So it was an x to the power of 3, it'll now be an x to the power of 2. The same thing here. I have a 2, at the moment it's x to the power of 2. So you bring the 2 in front, and then 4 multiplied by 2 gives me 8. and the power of x decreases by 1, so it becomes x to the power of 1. Now I want you to realize here we've just got a plus x. You should view that as x to the power of 1. So the same rules as the previous two, the 1 comes in front, so it's just plus 1, and then the power of x decreases by 1, so it becomes x to the power of 0. Now, or in other words, x to the power of 0 is just 1. So the derivative of x to the power of 1 is just 1. The x is completely gone. And the derivative of minus 2 is just 0. There's no x's there, it's just eliminated. So that's your first derivative. But the question asked me to get the second derivative. So I need to differentiate this answer. And this one is called f dash dash x. So I follow the exact same rules. I have an x to the power of 2, which means the 2 comes in front. 2 multiplied by minus 3 gives me minus 6. And the power of x needs to decrease by 1, so clearly it becomes x to the power of 1. And in this case, I have x to the power of 1, so the 1 comes in front, and it's just plus 8, x to the power of 0. Or in other words, it's just plus 8. Okay, and the question asked me to find the value of x for which the second derivative is equal to 0. We've worked out the second derivative, f dash dash x, is minus 6x plus 8. So all you need to do is let this equal to 0 and find the value of x. So I let minus 6x plus 8 equal to 0, and I added 6x to both sides, in which case I can now say that 8 is equal to 6x. In order to get x on its own, I just divide both sides by 6, and x is 8 over 6, which simplifies down to 4 over 3. So this is your final answer. The value of x when the second derivative is equal to 0 is 4 over 3. So I hope all of this video makes sense. If there's anything there that you'd like me to explain differently or you're unsure of, just send me an email or let me know in class or leave me a message at the bottom of this video and I'll explain it differently.